So we will continue with our topic, which is topic 14. This is a part of topic 14. So monitoring currents. To measure currents, you need three basic tools: an observer, a floating object, or a drifter, and a timing device. Okay, an observer stands on a ship, throws the drifter into the water, and then measures the time that it takes the object to move along the side of a ship. As technology improved over time, oceanographers began using mechanical current meters. A ship would deploy a meter, and usually some sort of rotor would turn and measure the currents. This is still the basic process today. However, there are more accurate and sophisticated instruments. Of course, the old method is an observer stands on a ship, throws a drifter, and then time measures the time that the object move along the side of the ship, and then by using the distance and the time, so we can calculate for the speed. That is how to measure the speed of the current before, no? During the early days. But today, it is already modern times, and we have more accurate and sophisticated instruments. Today in the open ocean, a drifter is similar to a buoy in the water that may be equipped with global positioning system technology or satellite communications that would relay data and information. Drifters can also submerge for long periods of time to measure ocean currents at a particular depth. The drifter would then resurface occasionally to send a signal with its data and position to observers on the land. So this is a sophisticated equipment which is similar to a buoy. So these drifters can submerge for long periods of time and then only resurface to emit or to send a signal with its data and position to observers on land. So in that way, the observer on land can calculate or can use the data for the calculation or the monitoring of currents. In addition to buoys, there are other tools that are used to monitor currents. The Doppler current profiler is commonly used to measure currents. It is normally deployed on the seafloor or attached to the bottom of a boat. It sends an acoustic signal into the water column, and that sound bounces off particles in the water. The instrument can calculate the speed and direction of the current by knowing the frequency of the return signal. The distance it traveled and the time it took for the signal to travel. Okay, many oceanographers also use radio antennas and high-frequency radio detecting and ranging systems or radar to measure surface ocean currents. Similar to the acoustic Doppler current profiler, this shore-based instrument uses the Doppler effect to determine when currents are moving toward or away from the shore or to measure the velocity of a current. So we will not study regarding the Doppler effect. This is only for your information. And we are not oceanographers. We are mariners. So this is only for your information regarding how they monitor current today. Okay, so at NOAA, or the National Oceanic and Atmospheric Administration in the US, oceanographers use knot to measure current speed. The term knot is defined as 1 nautical mile per hour. So 1 nautical mile is equal to 1.852 kilometers. 1 knot is also 51.444444 centimeters per second. Or 1 knot is equal to 0.51444 meters per second. So even if you use how many fours, so you will arrive at nearly the same answer. So this is actually the conversion. No? But in the NOAA website, it is indicated there that they are only using 1.85. But we are mariners. I do not want to give you that data, 1.85, because we are using one nautical mile is equal to 1,852 meters. So that is our conversion, being a mariner. We will not use what is being used in the National Oceanic and Atmospheric Administration, because they only use 1.85. Although they also use the same 51.444 centimeters per second, but only a few force. Okay, measuring wind currents. Large-scale surface currents can be predictors of weather trends or of how marine life move around entire ocean basins. However, smaller regional or local scale currents also occur that affect ocean travelers and marine life. Early sea voyagers relied on their knowledge of sea conditions, including large and smaller scale currents, to travel safely from port to port. Understanding currents is important for navigating traffic in harbors and shipping lanes. There are several methods that can be used to study the direction and speed of currents. Early mariners observed drifting objects and measured the distance they traveled over time to obtain speed. Modern methods also rely on this principle. But of course, as I explained in the early part, we use now the sophisticated instrument, although the same principle is being used. These are methods and devices used to measure currents. So this is flow meter. Flow meters are small, often handheld devices used to measure current flow. Water current spins a propeller as it moves past the meter. Okay, water current spins a propeller as it moves past the meter. The amount the propeller spins can be correlated with current speed. Some meters can also report the direction of water flow. Flow meters are useful in smaller bodies of water. So this is an image of a flow meter. And then another one is we have the clad cards. Clad cards are small blocks of plaster or a similar type of material used to measure relative flow rate between sites. As water current flows over the blocks, they dissolve. The faster the water flow, the more the clad cards dissolve. So clad cards are useful tools for measuring water flow near ocean bottoms. So you can see here the image. It is in the bottom of the ocean. And that is the principle being used, which of course we will not study regarding it, only for your information. And another one is the shallow water drifters. Shallow water drifters float near the surface of the water and are pushed by the predominant surface current. The distance traveled, time, and direction of a drift can be measured by an observer or GPS device. The picture is a Davis drifter which uses underwater sails moved by current flow. Okay, next one is deep ocean drifters. Deep ocean drifters flow with the current below the surface. They are programmed to descend to a predetermined depth for several days and then rise to the surface. While underwater, they record their position and then transmit information back to scientists when they surface. Deep ocean drifters are useful for long-term deployment in deep water as they can surface and sink through many cycles. So you can see the image here. This is also an explanation of how it goes. So this is the Argo float mission, or deep ocean, a type of deep ocean drifter. So this is your float, profiling float, and then it can descend to drift depth, and then it will descend for 3 hours, no, with this speed, minus 10 centimeters per second. So, and then it will drift for 9 days. And then it will begin profiling to collect temperature, salinity, and pressure during ascent. So it will again ascend. And then when it surfaces, it will transmit signal to the satellite and to the shore station. So this is actually by the National Oceanic and Atmospheric Administration. Okay, next is the acoustic Doppler current profiler, or ADCP. An ADCP emits sound pulses underwater and then measures the frequency of the sound bouncing back off the water particles. If the water particles are moving away from the ADCP, then the frequency will be longer. If the particles are moving toward the ADCP, then the frequency will be shorter. ADCPs are useful for measuring flow in bays. They can also be mounted on the bow of ships. And then we have the shore-based current meters. Shore-based current meters send out sound signal and measure the frequency of sound bouncing back. These instruments bounce sound off wind-induced surface currents. Shore-based current meters are useful in measuring surface currents, and when multiple meters are used at once, current velocity maps can be generated. So this is actually just like an antenna, which is near the shore, and it can, with its principle, it can measure current in the nearby ocean. Okay, so next is we have current information from pilot charts. Okay, pilot charts depict averages in prevailing winds and currents air and sea temperatures, wave heights, ice limits, visibility, barometric pressure, and weather conditions at different times of the year. So we have studied this in um, other subject. But here, that's why I made it in bold letters. It is also giving information regarding currents. So each volume is an atlas of 12 pilot charts, each depicting the observed conditions for a particular month of any given year. So you have already an idea of this, I know, because I am your teacher who explained this before, no? So the charts are intended to aid the navigator in selecting the fastest and safest routes, with regards to the expected weather and ocean conditions. The charts are not intended to be used for navigation. So the pilot charts are only useful as an for an information during your voyage, but do not use it for navigation. It is not intended for that use. Okay, so this is an example of a pilot chart. Okay, so you can see there are instructions written all over islands, no, or all over the mainlands. And the green color is regarding or about surface currents. No? And also the use of chart, there is an explanation. Okay, so here is about the surface currents, which is in green color. So you can read the information. The monthly stream and drift currents shown on this chart by green arrows indicate in general the currents that may be expected. So generally, sufficient data are available to delineate the prevailing current pattern and to determine the mean speed. However, the user is cautioned that changes in wind direction, speed, and duration can change local currents both in direction and speed. So if the current is not so strong, sometimes it is affected by the change of direction of the wind caused by low pressures. So you can only rely this without the effect of, or you have to take the effect of the low pressures that you will encounter. That's why now, even if you have these pilot charts, we are now using um, information from service providers regarding weather, currents, and the best way to uh, put your waypoints. Okay, so the arrow is prevailing direction. The thick arrow or arrow in bold. And then the, in broken line is the probable direction. So the number is mean current speed in knots. And so this broken line also, double broken line is approximate limits of equatorial countercurrent or countercurrent. Okay, so there is also an explanation of the wind roses, but this one is not our topic for today. Okay, so these are the green arrows, which are indicated on this pilot chart. So this is these arrows coming from Japan. Surely these are the Kuroshio, which is going east and connected to. So this is probably connected to the South Pacific currents. And then on near the coast of the US, it will also follow what is we have learned already in the circulation, which is clockwise direction. So some of them will go here, and this will be the California current. And some of these currents will go up to join the Alaska current, if you remember, no? Now, if you can see, there is an upward going current near the shore, especially here in the California. So this is actually the Davidson current. Okay, in the Philippines, there are also predominant currents. Okay, so we have also the currents even here in the Balabac Pass. So we have also a strong current there, and so on. No? So this is only an example. Pinalaki ko lang yung pilot chart for you to see. Okay, next is current information from sailing directions. Sailing direction en route. This is for the US. Of course, there is also the Admiralty sailing direction, which you can also use. No? But I just put here an example. I use the US version. No? But maybe you cannot see this on board because most vessels are using the Admiralty series. Okay, so the sailing direction include detailed coastal and port approach information, supplementing the largest scale charts of the area. Each publication is subdivided into geographic regions called sectors, which contain information about the coastal weather, currents, ice, dangers, features, and ports, as well as graphic keys to standard nautical charts available for the area. So it is still giving information about currents. Okay, so this is an example from the sailing direction regarding tides and current. So this is actually an excerpt, no? In screenshot ko lang. An excerpt from the sailing direction. Anyway, that's why I use this sailing direction because this is free. Free for download from the NGA website, the National Geospatial Intelligence Agency of the US. No, so they are publishing this publication and now given for free. Dati binibili pa to, no? But now it is given for free. So I do not know the reason why it is free, but I think because today we are now using the ECDIS and the electronic information. So maybe all of the contents of this can be also in the electronic type. Although this is already an electronic type because it is an ebook. Okay, so this will also be our activity for today. This is the information from the sailing direction en route Philippine Islands. So we have the Verde Island or the Verde Island tidal current. So passes south along the west coast of Luzon and deflects some of its water into Manila Bay. It continues along the coast as far as Punas Point and then divides into two branches. One branch set northeast around Tayabas Bay and north and east of Marinduque and through Mompog Pass. It then reunites with the other branch. This branch passes southeast along the Mindoro coast as far as Dumali Point, then continues east and south of Marinduque as far as the Bondok Peninsula. It then meets the flood current from the Pacific entering through San Bernardino Strait. It has been observed that upon arrival of Bondok Point with a fair current, a reverse current has been experienced in passing its meridian. The north part of the Verde Island current, which follows round Balayan and Batangas Bay, reunites with the main current in the vicinity of Verde Island. It produces violent rips and eddies in that part of the channel between Malabrigo Point and Escarco Point. So those are the information regarding current from the sailing direction en route Philippine Islands. So our activity is you need to download a chart or map or a screenshot of a Google map to be used in drawing arrows to indicate the information about the Verde Island tidal current from the sailing direction. So, okay, I'll just need to explain the activity and then you will do the activity and maybe you can pass only. You can pass the activity in the LMS. I will make a submission area. But I need to explain how you will do it. No? Okay, so listen. Okay, so you can download a chart if you can download or a map or a screenshot of the Google map to be used in drawing arrows to indicate the information about the Verde Island tidal current from the sailing direction. So I will post a screenshot in our LMS regarding this. Ito. Wait. So regarding this information, no? So these are the information from the sailing direction en route Philippine Islands. So this is actually, if you know already the Verde Island, no? So there is also a Verde Island tidal current that passes south along the west coast of Luzon. So it means not only in the Verde Island Passage, not only in that area, but also in the west coast of Luzon, there is a tidal currents which is called the Verde Island tidal current. So using this information, you need to draw arrows indicating the direction of the Verde Island tidal current. So ititrace nyo yung lalagyan nyo ng arrow kung saan papunta yung Verde Island tidal current. So you need to use all of the information. So in that case, if you can do it perfectly, then it means when you become second mate, you can also delineate the currents that are processed from information from the sailing direction. So naintindihan niyo ba our formative activity? you can go to the Google map and then just write arrow indicating the Verde Island um, tidal current. Even if you do not put a name or even if the arrow only, no? Basta yung arrow lang, yung Verde Island current lang, no? Okay, anyway, if you do not understand some of it or if you do not understand regarding this, then just ask me in the group chat so I can explain, no?
Sir,
Yes.
ipo-focus ka lang po sa Verde Island or isasama din po yung sa halimbawa po yung Balayan Bay?
Hindi, yung mag-focus ka doon sa Verde Island tidal current. Hindi yung Verde Island lang. So, meron din papasok sa Balayan Bay, meron din papasok sa Batangas Bay. Nakalagay doon, di ba? Tapos,
Yes, sir.
Near Marinduque, meron din. And west coast of Luzon, meron din siya, di ba? Before coming in the Verde Island Passage, may ano na Verde Island tidal current. So, yun ang arrow na ilalagay mo, no? Tapos, but do not put yung doon sa San Bernardino. Hindi na yun. Yung kasalubong na.
Apo. Apo.
Kung ano
Thank
lang
you
yung
po, sir.
dinidescribe. Okay, sige.
Sige po.